Hello everyone. In the last class, I have discussed with you about the concept and definition of new media. I have highlighted the characteristics of new media, and I also discussed with you about the differences between new media and old media, the mass communication and media communication, and I focused on interactivity as one of the decisive feature of new media. Today, I will look into the evolution of new media. So here we begin. New media is a 21st century catch-all term used to define all that is related to the internet and the interplay between technology, images, and sound. In fact, the definition of new media changes daily and will continue to do so. A new media evolves continuously. What it will be tomorrow is virtually unpredictable for most of us, but we do know that it will continue to evolve in a fast and furious ways. The term new media is a broad term which encompasses almost all the new age innovations that have taken place in the domain of communications. Coming out from the audiovisual era when television and radio were regarded as the zenith of communicative success by mankind, we have now moved towards a world woven by the internet. The barriers of geography have been bridged like never before, and the world today can be seen by the press of a button on our mobile phones. The revolution in the telecommunication sector also has been exemplary, and therefore the most innovations in the world of communication are witnessing a marriage between the world of internet and mobile telephony. So to understand the world of new media in greater details, let's analyze how the sector evolved gradually. The first and foremost pillar of the new media paradigm was undoubtedly the internet, since it facilitated the instantaneous communication of thoughts and ideas to a large audience with the potential for immediate feedback at a reasonable cost. So I will start with the evolution of internet. So regarding this origin of internet, which can be traced to 1957, that was the period which was marked by competition between two superpowers, USA and USSR, for technological supremacy in the prevailing Cold War atmosphere. The Soviet Union won the race by launching Sputnik. Sputnik was the world's first artificial satellite, and it was launched on 4th of October 1957. USA responded to the challenge by setting up the Advanced Research Project Agency, that was ARPA, within its defense establishment. And ARPA's mission was to adopt the latest technologies uh, for military application in order to regain and maintain American technological lead over USSR. In 1957, the US government formed the Advanced Research Project Agency, which was a segment of Department of Defense, which was charged with US leadership in science and technology with military applications. So, the two important governing principles of the Internet, namely the galactic network and packet switching, took shape in 1961 and 62 and were brought together in an ORPA program started in 1962. Uh, so, uh, John Licklider, who was a scientist of Massachusetts Institute of Technology, that is MIT, who had been working on the galactic network concept, was the leader of the program, and he proposed a global network of computers and moved over to Defense Advanced Research Project Agency to head the work to develop the network. So the first recorded description of the social interaction that could be enabled through networking was a series of memos written by Licklider of MIT in August 1962, which he discussed and where he discussed actually the galactic network concept. So Licklider was the first head of the computer research program at DARPA, starting in October 1962. While at DARPA, he convinced his successor at DARPA, Ivan Sutherland, Bob Taylor, and MIT researcher Lawrence Z. Roberts of the importance of this networking concept. So he had visualized a computer network in which every node would be accessible to everyone at every other node. Another person was Leonard Kleinrock of MIT, who was generally the pioneer in packet switching. Uh, Kleinrock at MIT published his first paper on packet switching theory in July 1961 and the first book on the subject in 1964. Kleinrock convinced Robert of the theoretical feasibility of communications using packets rather than circuits, which was a major step along the paths towards computer networking. So we see that the packet switching technology breaks up every message into packages, puts this into envelopes bearing the addresses of their common destination computer, sends the envelope separately through a transmission network so that they find their own individual and possibly separate paths according to network traffic conditions, and reassembles the packages into the original message at the receiver's end. According to some sources, however, packet switching was invented in 1962 by Paul Barron at RAND, the Pentagon think tank. So the implementation of this system meant that unlike conventional links such as a pair of wires between two telephones, the transmission of information would not depend on a single route. This has two security related advantages, even if a part of the network were destroyed, say by Soviet missile, transmitted information would still reach its destination since the packets would find another path. And second, it would be more difficult for enemies to eavesdrop on the messages being exchanged, since at no point on the network other than its terminal point, that is sender's end and receiver's end, would all the data packets be available. So the team of scientists at MIT, RAND, and the National Physics Laboratory of UK had all been working on networks for computers dispersed over large geographical areas without any knowledge of one another's effort. Their ideas, as well as a protocol to enable the computers to send and receive messages and data to other computers, were brought together in October 1969 to successfully link computers at the University of California in Los Angeles and Stanford University in such a way that the users at one location could access files stored on the computer at another location. So we see that in the late 1966, Lawrence Z. Robert of MIT, who was a researcher, went to DARPA to develop the computer network concept and quickly put together his plan for ARPANET, publishing it in 1967. And the ARPANET eventually paved the way for the invention of the Internet. So ARPANET was a network to connect the major computers at the University of California at Los Angeles, the University of California at Santa Barbara and Stanford Research um, Institute and University of Utah. Yeah, University of Utah. Then ARPANET was designed to allow continued communication if one or more sites were destroyed. Unlike today, when millions of people have access to the internet from home, work, and public library, ARPANET served only computer professionals, engineers, and scientists who knew their way around its complex working. And the US Department of Defense laid the foundation of Internet roughly 30 years ago with a network called ARPANET, but the general public didn't use the Internet much until after the development of World Wide Web in the early 1990s. So this was the birth of the very first of those networks which would later coalesce into the Internet. Named as ARPANET, it grew to include 23rd computers by December 1971. There are also other developments, like other networks also began to be set up and important technological advances followed. One of these being the development of email by 1972. The first international connection on ARPANET was established in 1973 for the University College of London. One of the most important milestone reached around this time was the development of TCP IP, jointly by scientists of ARPA and Stanford in 1974. This TCP/IP enabled different networks to communicate with one another and made possible the open architecture which the net has today, making it the galactic network of Licklider's vision. The year 1974 also marked the opening of the first public data network called Telnet, owned by Stanford University. We will discuss about Telnet later on. Mm, Another important development that would make the net what it is today were taking place in the sphere of hardware as well. Till the mid 1970s, network computers were all large mainframes belonging to big corporations, government institutions, and universities. But small microcomputers and versions of TCP/IP suitable for this were also being developed. And these microcomputers were the predecessors of the personal computer used today and by extension of the notebook or laptop. So we see that with the rise of internet technology, computer technologies have also evolved, which we will discuss later. Then we look at Usenet. Usenet is a large distributed system of messages involving millions of people from all over the world. Too many messages are sent every day, so they are divided into news groups, with each news group concentrating on one topic like jokes, recipe, mathematics, philosophy, computers, then biology, and it can be just about any subject you can think of has its own group. Unlike the commercial services such as America Online and CompuServe, there is no central authority that controls Usenet. Thus, whenever the user decide that there should be a new discussion group, they form one. So Usenet itself is often referred to as news or net news. The intellectual contribution of each news group is called posting, and each Usenet site is run by the people who use it. So each Usenet site is run by a person called news administrator. His job is to manage the site. Lack of central authority is what gives Usenet its charm and is what distinguishes it from other discussion group systems where there are rules and people in charge to authorize. So we see that one factor that influenced the philosophy of internet, in which mailing list, email discussion groups have an important place, was the birth of Usenet. So Usenet uh, took place in 1979, and in USA Uh, Postgraduate students at Duke University and the University of North Carolina created a network, and this network linked computers at these two institutions, uh, and it is called as Poor Men's ARPANET, and it made access to the students better because ARPANET was thought to be extremely expensive and also require political connection. So the problem with ARPANET was that there were both technical and procedural restrictions on its mailing list. It was so because the main functions of the network were to serve as a vehicle for carrying out research on computer networking and as a means of long distance collaboration among ARPA contractors. Moreover, its ARPANET mailing list had a central control that would determine what material could be posted on it and who received the post. Usenet's main function, on the other hand, was to host discussion groups, and unlike ARPANET, receivers on Usenet groups controlled what they received, and this facilitated and these features, as well as its accessibilities to those who were outside ARPANET's ambit, made Usenet popular in academic circles, and it was linked with ARPANET soon. Then we look at the expansion of net, even as the networks continued to expand and proliferate in the USA. Through the 1970s and in the early 1980s, the trend was also evident in Europe. UNIT was set up in 1982 that linked the networks in US, Scandinavia, and the Netherlands. Another network called EARN was European Academic and Research Network. EARN, European Academic and Research Network, that was set up in 1984, and in 1982 was the year in which TCP IP was adopted as a protocol for all the network. The 1980s saw an expansion of net across the world, and in 1986 many European countries like Canada, Denmark, Finland, France, Iceland, Norway, Sweden all joined the US National Science Foundation's NSF-NET, which had been created in 1986 and had become one of the networks connected to the internet. This expansion continued through the following years, and India also joined the NSF-NET in 1990. Then another development was list servers along with this email. List server is a variation of email which function primarily to receive messages from individuals and then to distribute them according to mailing list. Members of this mailing list then constitute a group of communicants who can carry on asynchronous discussions much the same way as users of computer conferencing system do. Then we have electronic bulletin board system EBBS, which are an emergent form of computer mediated communication activity about which we will discuss later. Then the original concept was that of the conventional community bulletin board as an area where public messages could be posted and read. In early 1980s bulletin board system were primarily established by computer user groups for the purposes of online distribution of software and related information. The messaging feature became increasingly popular as members found that the posting of bulletins soon resulted in interactive discussion. Uh, then we see that chat mode, which is an important and significant example of text-based computer mediated communication. Most computers used for communications have at least a rudimentary form of this feature installed. The exchange can be character by character, line by line, or in multiple line blocks. In character by character mode, the receiver see each character as it is typed by the sender. In line by line mode, the message is not sent until the sender presses the key, or in multiple line block mode, several lines are composed before the message is being sent. So we will discuss about the CMC, even the synchronicity and asynchronicity, which are the two significant features of computer mediated communication later on. But chat is in fact a development which has contributed to the rise of internet. Then we see that in early 1970, so as early as 1975, with relatively unsophisticated conferencing software, that is forum, uh, Jack Valley, Robert Johansson, and Kathleen Spangler of the Institute of Future presented a report on computer conferencing as an altered state of communication with significant social implications. Their report presented three main issues. Those were alterations in time and space, text-based interaction, and socio-emotional content. So these were the next round of new media developments. So electronic mail, list servers, then chat mode, then forum, completely revolutionized the way people communicate. Then we will look into the rise of internet. When you say internet, internet is a massive collection of computer networks that collects millions of computers, people, software programs, databases, and files which interact continuously. Simply, internet is called the net, a worldwide system of computer networks, a network of networks. So Internet is a vast collection of globally available information which can be accessed electronically, information which is of practical use for business, research, and technical purposes. It is a means of electronic commerce, marketing, buying, and economic and financial data research. It is also a collection of hundreds of libraries and archives on every conceivable subject. So it is also a vast storehouse of information related to your hobbies, travel, health, entertainment, games, software, and so on. So internet can be compared to a postal service, which is a packet switch network. Here you do not have a dedicated piece of network. What you intend to send is mixed with other messages, put in a pipeline, transferred to another post office, and sorted out again. So the postal service is an apt analogy that can be used to understand the working of internet. We will discuss about deliberate on the growth of internet in India later on. So I'd like to discuss here about this World Wide Web because it is quite important to relate to the rise of internet. World Wide Web is a network of electronic files stored on millions of computers all around the world. Hypertext, which you have come to learn already, lines these resources together. Uniform Resource Locator, that is URL, are the addresses used to locate the files. Every URL is unique and identifies one specific file. So we see that the World Wide Web facilitated the proliferation of websites, and it was created by European Council for Nuclear Research, that is CERN, which is a professional body founded in 1952 with the mandate of establishing a world-class fundamental physics research organization in Europe. The first ever website belonged to CERN, that is European Council for Nuclear Research, uh, and was created in 1993. So the original idea came from a young computer scientist, Tim Berners-Lee. It is now managed by a worldwide consortium. The worldwide consortium is funded by large number of corporate members, including AT&T, that is American Telephone and Telegraph, which is an American multinational conglomerate holding company, then Adobe Systems, then Microsoft Corporations, and Sun Microsystems Inc. It the purpose of it is to promote the growth of web by developing technical specifications and reference software that will be freely available to everyone. So web is known as client server system. Computer you use is the client. The remote computers that store electronic files are the server. To visit the website, you can enter the address or the URL of the website in your web browser. Browser requests the web page from the web server that hosts the requested site. The server sends the data over the internet to your computer. Your web browser interprets the data, displaying it on your computer screen. Then we look at the TCP IP and IP address, that's Transmission Control Protocol and Internet Protocol. So each computer on the internet has a unique number called IP address identifying the host computers so that packets of information reach the correct computers. So you may have to typewrite IP addresses when you configure your computer for connection to the internet. TCP/IP is the networking protocol on the internet. For TCP/IP to work, your network interfaces need to be assigned IP addresses. And IP addresses is a 32-bit number that uniquely identifies a network interfaces. So the IP address is assigned to a network interface card and not to a computer. So if you have two network interface cards, then each card is assigned an IP address. The 32-bit IP addresses are normally expressed in dotted decimal format with four numbers separated by periods. The examples I have already provided here. The four decimal number which are separated by periods like 151.201.123.132. And these numbers can be in the range of 0 to 255. So IP addresses are organized from left to right. Next, we have domain name system. Domain name system is an important innovation related to TCP/IP, which has made the internet easy to work with, even for non-specialists. It has simplified the addresses of host computers on the internet, which are a series of numbers separated by dots such as 135 like 2340 then dot 0 dot 87 like this way, and through an easy to remember system or of tree like hierarchy, and is used for sending information from one computer to another under the TCP/IP protocol. Since the internet started as a network confined within the USA national border, the first domains didn't have any provision for naming host computers located in other countries. So, DNS is a critical part of Internet's technical infrastructures. It correlates a numerical address that is IP address to a world. So every computer that hosts data on the Internet has a unique numerical address. For example, suppose the numerical address of Tezpur University is 198.137, then 204.100, some numerical address dotted with decimal. number, but since few people want to remember four string of numbers, domain name system was invented, and domain name system is a critical part, as I have already mentioned, of this whole internet technical infrastructure. So to access the Teju website, we could type its number into the address box of our web browser, but most people would prefer to use www.teju.arnet.in. In this case, the domain name is teju.arnet.in. So we see that the domain name system is a distributed Domain name system is a distributed scalable database of IP addresses and their associate names. It is a distributed system in the sense that, unlike the host files, no single computer contains all DNS information in the world. The DNS data, domain name system data, is distributed across many name servers, and scalability of DNS server refers to increase in the total volume of DNS data request from the machines from the same data without significantly increasing the querying time. So when we say scalability of DNS. So scalability refers to the ability of a computing process to be used or produced in a range of capabilities. To scalability basically refers to the capacity to be changed in size or scale. So to understand the DNS and the way it is used, we need to understand the internet naming structure. So, so we see here that www indicates the machine is a part of www, that is World Wide Web. .com indicates the top level domain that the machine is a part of. It includes .com, .edu, .gov, .in, and so on. A domain name is a way by which a company can uniquely identify itself on the internet. Registering a domain name on the internet is equivalent to register a company's name at company's house based on top level identifications. There are basically two types of domain. One is non-geographic domain and geographic domain. So when we say non-geographic domain, we have commercial organization, then educational institutions, then we have military setup. For commercial organization, there is .com. For educational institution, there is edu. For military setup, we have mil. For government setup, there is gov. For other organization, there is org. For networks, there is net, net. For international organization, there is int, and so on. So the geographic top-level domain use basically the two-letter country designation. So we have AU for Australia, CA for Canada, DK for Denmark, FR for French, GR for Greece, IN for India, JP for Japan, US for United States, and so on. And then we have HTML. So we see that HTML stands for Hypertext Markup Language, used to create and organize documents on the World Wide Web. The web, by extension HTML, is invading a significant part of our lives. At work, the web serves as advertising medium, as a communication tool, and even as a message center. At home, web has become integral even to television set. So you see, throughout the world, companies, individuals, and organizations are providing, retrieving, and publishing information with the help of HTML. So HTML stands for Hypertext Markup Language. It is not only a programming language but also a markup language. HTML was first proposed in 1989 by a researcher named Tim Berners-Lee. HTML is a member of a family of markup languages called Standard Generalized Markup Language, that is SGML. It took a shape of a subset of Standard Generalized Markup Language, which is a higher level of markup language that has long been favorite of Department of Defense. So HTML lets user to format text, add graphics, sounds, videos, and save it all in a text only or ASCII format that any computer can read. Then we see that the function of hypertext and hyperlink. The glue that holds the web together is called hypertext and hyperlink. These features allows electronic file on the computer to be linked so you can jump easily between them. On the web, you navigate through pages of information commonly known as browsing or surfing based on what interests you at that particular moment. Web pages are written in a computer language called Hypertext Markup Language or HTML. Hypertext allows creating a link in a web page which leads to any kind of pages on the web. Hence, information on the web can be accessed from many different locations. Then we have HTML editors. HTML editors make it easy to write web pages, while it is possible to write a web page using just the text editor on your computers. Most web designers find that it is much easier to efficiently use an HTML editor. So HTML editor gives you features that are not usually available in plain text editor. Most of these are what you see is what you get editor. This is what you see is what you get editor. WYSIWYG. So you see that HTML shares important characteristics with its SGML parents, a character-based method for describing and expressing content. Some examples of web browsers are Microsoft Front Page, Netscape, Composer. Um, I'll discuss about it later on. Then extensible markup language, that is XML, that will allow you to create your own tags. So content created with the help of XML is completely separated from formats using style sheets. Um, this is all for today. If you have any difficulty in understanding any concept, then drop me a message in the WhatsApp group. Your queries and confusions will be addressed. Thank you so much.